Hello everyone. Uh, in this tutorial, we'll have a brief walkthrough over the code for the recommendation system, the recommender. So the recommender that we've built is basically for the movie lens dataset, which you can find on the Group Lens website. So let's just quickly walk through the recommender itself. So we want our recommender to to perform a bunch of operations such as uh, get the top ratings for a particular user or uh, get the rating for a specific movie for a particular user or add a new user to the dataset. So it makes sense that we kind of modularize it into different functions. So we create a class called recommendation engine, and then we have a different set of functions to take care of individual tasks. We'll look into each of these functions. But before that, let's look at the init function. So if you have any programming background, you'd know that for C++ and Java, we have constructors. So and and for any method that we call, we kind of implicitly pass the reference to the object that is calling it, which is then accessed using the this keyword. So in Python, you can think of init as kind of the constructor for the recommendation engine class, and instead of using the this keyword, we have to explicitly pass the reference to the object, and it is accessed using this keyword called self. Now let's dive into this method. So this is just a bunch of logging. So we, for now, let's just assume that we have been giving the Spark context from the uh, from our PySpark, and we'll just use it to perform some functions. So, and also the dataset path argument that it takes, it basically is the path to the S3 bucket where all of our data is hosted. We'll look into this variable also again. This, okay. So here we read the text file. We read it's basically a CSV file which contains the movie ratings. It contains the user ID, the movie ID, the rating, and the timestamp. There are four attributes. So in this line right here, we are basically reading that data file from this path. We are rating ratings.csv from the path that we specified, and then we store it as a raw file inside the ratings raw RDD, and then uh, we store the header inside the ratings raw data header. We take the first element of it. Now, like I said, the data contains the user ID, the movie ID, and the rating. So, but to be able to do useful work on the data, we need to first typecast into. So we typecast the user ID as int, the movie ID as int, and the rating as float, and then we cache it. And similarly, we also read the movies.csv, and then we store it into the self.movies underscore RDD after similarly typecasting into int. Now the movies.csv file holds the ID, the movie ID, and the name of the movie. So when we are performing training on the data, we can simply work with the integers associated with the corresponding movies, but when we want to display to the user, we want to display the movie name. So that's why we will be using the self dot movies RDD later. And then count and average ratings is a function that is defined here at the top. So like we can see here, this basically takes a tuple which contains the movie ID and the ratings iterable, and it basically returns the number of ratings given to that particular movie and the average rating. So for that, what it does is it simply first calculates the length of the iterable for that movie, and then for that particular movie, it kind of takes the sum of all the ratings and it divides by the number of ratings to get the average. We'll need this because later we will see that to give to be able to give useful recommendations, we only want to recommend movies that have a certain number of ratings already, and that's why we'll be using this. And we also initialize a bunch of different parameters that the model is going to use. So for this recommender, we use the ALS, that is alternating least squares model, and it takes a bunch of parameters: rank, seed, iterations, and regularization parameter. Uh, the thing about rank is the way alternating least squares works is it kind of maps the user taste and the um, the genre or some characteristic of the movie into uh, an intermediate latent space, right? And after that mapping is done, it uses that mapping to map the users to newer movies of which have the similar characteristics, the characteristics which that user likes. So this rank basically gives us the length, the size of that latent dimension, and this is the seed and number of iterations. Regularization parameter is something that we use to make sure that we do not overfit the data, and it's generally a very small floating point. So this was just the constructor for the recommendation engine. So briefly, we just gave the data path for our data, and then we loaded the ratings.csv and we loaded the movies.csv into corresponding RDDs, and we initialized the parameters for the model, and now we're going to train the model using this method train model. So this is actually a very simple method. It takes the parameters that we uh, pass to this method, and als.train is uh, the command that it uses to train the model on the given set of parameters. So after this, our model is ready, and we'll see how we can use these functions to get a bunch of recommendations. Now let's look at the other functions. Now, when a user wants the top ratings, top recommendations for himself, so uh, they'll just specify that the number of recommendations that they want. So the data that we'll have is the user ID, that's the person who wants recommendations, and the number of recommendations that they want, that's the movie count. So whenever we want such top recommendations, so we'll call this function. So inside this function, now we only want recommendations for movies on which a particular user has not given his ratings. So how do we find that out? We do that by using this filter method. So we filter out all uh, the movies for which uh, the rating RDD that we had, the ratings RDD that we had, uh, in which the user ID field does not match the user ID of the user that wants recommendations. And so we get the set of all the uh, possible movies that we can recommend to this user and store it in the user unrated movies RDD. Then we take this RDD and we call this method called self dot predict ratings. So let's see what this method does. So this predict ratings method simply takes, like it says here, it takes the user ID and a movie ID formatted RDD, and it returns an RDD which contains the recommended movies in the form of movie title, movie rating, and number of ratings. So how it does this? Let's look at it. So earlier we saw that we trained the model using the ALS and we stored it into self.model. Now we'll use this model to get predictions. So the predicted rating RDD is where we'll store our results. So the predicted RDD is equal to self.model or predict all and the RDD that we passed it. So, and after this, we will want to take the movie itself and the rating that it was provided, and then we'll store it as an RDD. So we use this map function and we store it inside this. Now, like we talked before, the user probably wants the names of the movies that he can watch rather than just the integer values that we have provided for our convenience. So that's why we'll take the output of this step and then we'll do a join with the movie titles that we initially loaded. And also, like we said, that we want the recommendations to be for movies that have a certain number of ratings associated with them. So we also join it with the movie ratings and counts dataset, which basically contains the number of ratings provided to each movie. So the output of this cascaded join is going to be something like this. So we'll have the movie ID, we'll have the rating that it's been provided, that the rating that it predicts. It'll have the title of the movie and the number of ratings. And this is probably not a very easy format for the user. So we'll flatten it out to have something like this. So we take the value that is returned by the predicted rating and then we filter it here. So we say that only give me the ratings that only give me the movies that have more than 25 ratings, and then we sort it according to the movies count. That is the number of ratings. So that's how we get the top ratings for a user. Another very interesting use case is to get ratings for a particular movie given a user. So now that we have this method called predict ratings, it's actually very simple for us to get ratings for a particular movie. So uh, we can simply give the RDD containing the user ID and the movie for which we want the ratings. So that's what we do here. So we take the information about the movie for which we want the rating and we have the user ID with it. And then we form an RDD using this information and store inside requested movies RDD, and then we pass this information to our predict rating method, and it returns us the result in the exactly same manner, and so this will return a specific rating for us. Uh, Another use case for us is to add another user to our existing set of users because say on the Movie Lens website, when a new user comes, it the user is asked to provide a set of ratings and from a bunch of chosen movies so that the recommendation algorithm has something to work on, so it can find a neighborhood of movies that the user might like based on the data it has given them. So for that we have this method called add ratings here. So let's have a look at this, what this file looks like. So we'll provide a ratings file to the recommendation engine. So this contains uh, the movie ID on the as the first argument and the rating that the user has provided to this movie. And then we'll use this data to arrive at new recommendations for the user. So inside the add ratings, we get the data in that format that we just saw, and then we create an RDD by using the parallelize method. And then we want to add this into our existing set of ratings. So we will do a union into the ratings RDD. And so after adding the new set of ratings, we also need to reevaluate the count and average ratings for each movies, because now we have additional rating information. So we do that and then we train the model. So after we have trained the model with the new user, we can again use any of these functions either to get the top ratings, the top end recommendations for the user, or to get the ratings for a specific movie for this particular user. So that's all for this. That's all about the engine.py, and